will start my talk about kappa-architecture. I like to start the talk with a local greeting, in this case, hola Barcelona. Let me introduce myself. I am data solution manager at Open Systems, a little data consulting company. I am also GDE Google Developer Expert for cloud. And another thing is that I co-author of the first Spanish free software book, La Pastilla Roja, and I was president of Spanish Linux local user group. Okay. Also, I am organizer of a couple of meetup. And today, I'm here to talk about kappa architecture. For me, it's important, very important, to explain what is that, because kappa architecture is a pattern that I use every day. So for me, there is a before and after when I understand how work kappa architecture. So we will have a brief history about the kappa architecture, how work the architecture, a little real example, because I think it's very important how to use the pattern in a real example. And I want to show you how the concept the evolution of the concept and the tools in the last 3 years. Okay, so we started with what is the kappa architecture. Everybody here know what is the kappa architecture before? Okay, better for me. The first time that the kappa architecture term was used was in a post in O'Reilly Radar, and Jay Krebs, the father of the 10 and the boss of the kappa architecture, wrote a post about what is the state of the land architecture, and he questioning about how the land architecture was, and he tried to find another way to do the things. So the first time was in 2014 in July when Jay Krebs started talking about the kappa architecture. Before that, who is Jay Krebs and why is it important for the kappa architecture? I don't know if you read this post, another post in, I think this post was in the LinkedIn blog. In this time, Jay Krebs was working for LinkedIn, and for me, this is another very important breakpoint in my life as programmer. In this post, Jay Krebs started talking about the log and how is the information, and how you can, what can you do, and how do you need to see the information. In this case, for Jay Krebs, all the information is a log. If you think about the click screen in the website, it's obvious that every time that a user visit page, you got a lot of events, such open this space, got some picture and whatever. And if you start thinking that all the information that you got in your system are a log, then you start thinking about the information in another way. Not just only with the log from a website, but if you can start with legacy databases or information for your customers, you start thinking that everything that's happening in a database, in a normal database, is a kind of log. And after that, you can model in your information system in another way. For me, this is very important. I recommend you to read this book. I heard log. Now it's free. It's about the printing, the print version of the log or the post of JCref. It's so easy because it's about 50 pages with a lot of graphics, so you can read in 20 minutes or, or in 30 minutes, no problem with this. But for me, it's very, very important to understand kappa-architecture and how work with data. Now, JCref was in this project. Almost this project was done when he was working in LinkedIn, Apache Kafka. Everybody here knows about Apache Kafka? Okay. For me, it's another very important tool. There is a lot of projects doing by JCref. Now is the co-founder and the CEO of Confluent. Confluent is the company that is working in the next generation of Apache Kafka. And they have a model with free Kafka and almost all the tools, and a premium tool for Kafka. Okay, so let's start in seeing who is about who is the normal flow in a system, more or less. This is a Lambda architecture example. As you can see, there is two parts. One part is a normal batch view. In this part, the information is stored in a permanent system, and this is very classic. And the other part is the streaming process. As you can see, you are getting information from the batch system and the streaming system. You merge this information and store as this new information, transformed, aggregated, or whatever, to produce new views about this information. This is good. That can work, and there is a lot of systems that use Lambda architecture, but there is some problem with this architecture. The first one is not an easy architecture. For me, it's a little complex. And if you see, you had two different technologies for the streaming part. In this case, are user storm. For the batch part, you can use it Hadoop or whatever. But if you see, you have two frameworks. Perhaps you have two different languages, two different technologies to stay in the same data, to try to merge and get information from this. If you want to try to debug if there is a problem with the data, you need to use two different systems to debug. You need to, when you need to solve something, you need to write the two versions of how you get the information finished. For me, this is more or less very complicated to maintain in production or to try to design system. How works more or less kappa-architecture? The main idea is that do you have an input, and we will see a more complex example like this, but you can read this input with only one framework, and we will see a couple of frameworks, and you can process in the information more in a simpler way. Let me show you an example. This is the state of the LinkedIn. I think 2 years after after they started the company. Okay. For me, this is very usual in the companies I work for. After a couple of years, you have a lot of systems, not only a website, CRM, a lot of application components that generate a lot of information in relational database, in logs, and whatever. Every time that somebody in the business part needs a report, needs data, this flow getting more complex. Do you need to talk with a lot of people from the DBAs people? Do you need another sources? It's a mess to try to finish a question, and all these flows or all these arrows starting growing and getting the thing worse. But if you starting thinking in kappa-architecture and thinking that every piece of information in the system is a log, you got something like this. You every time a single piece of information is generated, you export the information to an stream data platform. In this case, Kafka, and you forget to need to talk with the DBA people, with the people that export a file to CBS or FTP or whatever. Every single piece of the system is published in the stream data platform. And after that, everybody that needs information in the system get information from this stream. Okay, so think about the normal flow of how the information is consumed. Somebody from the business part make a request, something like, I want to build a real-time dashboard with the customer sales or whatever. So you don't need to start in thinking or talking about with the people that manage the information. You only need to know where is the place in the stream data platform to get the information and starting working with this. That's make more simpler simple all the process, and that is the main idea of the Kafka architecture. You got all information, you publish all information, and you consume and you prepare, make aggregation, transformation, or whatever in the original information. If you compare this with the previous, this is a mess, and the most is like spaghetti, and my friends tell something that this is not spaghetti, and this is more just lasagna, because it's a multi-layer boost with a lot of information. Okay, so I wanted to show you what is the main tool we use to implement this, and I will show you how use this tool or framework to implement a little project. The first one is Apache Kafka. For me, Apache Kafka is a really good project. I mean, the Kafka is in the top 5 on my project, because in general the team after the project is absolutely great. The evolution of the product is awesome, and this kind of distributed machine system for me is perfect. I compare with a lot of system, and Apache Kafka now is the best one for almost every project. I didn't mention this, but Uber is using Kafka, and all the information that is produced in Uber, and this is 20,000 million even every day, is publish it into Kafka and manage it by the rest of the process that needs to work with this. Everything from the taxi position, from the payment, the request, and whatever. 2,000 million misses every day. It's not bad. I think that is a good example that what is the limit or not of the system. You can manage that volume. Okay, so just for making a very fast description of Kafka, you can make a Kafka cluster that can grow in horizontally without any problems. So you can manage volumes like Uber. Okay, so the important part is that you have applications that produce data that is being published in the Kafka system. The important thing is you can do it with every kind of language. You can do it with Java, with there is a REST API, so you can make it even with Carve or wget or whatever, PHP, whatever language that speak REST API, okay? In the other side are the consumer. The consumer are the application that get read the information and manage the information you have. You can have all the consumers you wish doing. They can read about topics. Information is organized about topics. The another interesting thing is the connector. In the last versions, I think the first version was the 0.9.0, lets you to define connector that automatically retrieve the information without the need to make the producer to get the information. In the old version, you need to make a little producer that reads from the database, something like MySQL or whatever, get the information and publish it in the Kafka cluster. With the Kafka connector, you can define, I have this database, this is the JBC connector information, so I want it to automatically, every 5 seconds or whatever you define, got the information and publish all this table in Kafka. This is very important because you don't need an external help from DBAs, from legacy application. If you have access to the database, you can get the information almost automatic. Okay, and there is also ways to automatically publish this to make consumer like every time I got an event in this topic, just store as in S3 from Amazon or whatever file system. Okay, this is more or less how Kafka works. The another important thing for me is that Kafka, the way Kafka is designed is that you got the information very fast, write a log in the hard disk, and after that you can consume this information, and every consumer can work in different ways. Okay, so also had the feature to make a kind of buffer, because you can define all the storage you wanted to have in Kafka. If you say to Kafka that you had 4 terabytes of hard disk space, Kafka managed to store the last 4 terabytes of data without any problem. So this is very important also because you can manage more information that you can consume in real time. It's really, really fast. By the way, the first version was writing in Scala, but when Jacob left leave LinkedIn uh, phone and starting his own company, Confluence. He decided to write in Java because he said that was more easily to write in Java than Scala. So the last version is writing in Scala, pardon, in Java. Okay, the another tool we use is Spark. How many of you are using Spark? Wow. It's a very good framework if you are working with data. For me, is in my top 5. Is another the framework in my top 5. Is for me is very impressive if you are managing data. The tandem Kafka más Spark is the winner horse for sure. I will not explain what is Kafka, pardon, Spark, Apache Spark, but in general, it's a framework to manage that can build cluster and manage in memory a lot of information, and you think you have your data is a kind of unified version of this, even you have multiple elements in the cluster. Okay, so with this expression, my favorite one is that if you have a lot of sources or data sources, if you have a schema, and when I say you have a schema, is you have a lot of CVS files or JSON files or whatever, you can do a Spark. You can use with this information with a Spark SQL, and you can write SQL statement, and that's work perfectly without any problem. So when you have a lot of semi-structured sources of information, you have with a Spark SQL, you solve a lot of the trouble to work with different sources, okay? But with the same way to manage this. Spark SQL is just one of the modules, but there is a lot of things more in Spark. The another thing very important for me is Spark streaming. Spark streaming is the way that Spark manages real-time information. If you wanted to read Twitter, the Twitter stream, or Wall Street trading information, or whatever that is produced and published in streaming, Spark streaming is perfect. There is a lot of sources. I think you can read from whatever you want, because there is driver for reading all the sources defined. And the thing is, all the time is the same interface, is the same API for all the modules of the Spark. I will show you in the next slide one sample of code, because for me that was another thing very important for me. I don't want it to write down a lot of code to do something I really like, some simple code is a kind of well, very, very important thing for me, okay? The another thing that we see in the next slide are the structured queries. I will explain this, but it's kind you can make queries over the real-time data. Even when I talk about real time, I mean near real time, but you only need to define what is the information and the transformation you want to do with the streaming information, and you got this information and can do whatever with this. I will show you this. Well, I really love Scala. I I need to say that even in a Java conference, for me Scala is a really good language, okay? And Sparrow writing in Scala. And let me show you a little code. This is a very simple uh, uh, two-line of code. The first one I am reading from one input, in this case, an streaming one. I am making a group by, classic, by action. I am defining what is the window of the data. I am defining how many time, in this case 1 hour, and I am making a count of the different actions. This is classic. I can do it with a secular sentence, but with this, I am just defining what I do with the data, okay? And in the second line, and this program work, yeah, I am saying that, okay, get the information. I am I transform it in the previous line, and just publish this with a JDBC server with this universal resources locator. Okay, so in 2 lines you are reading from a streaming, make some transformation, and publishing this streaming. I can save in whatever. I can send this to another streaming sources. I can do whatever, but in this case for me it's very important because almost all my customers want to have a source of information that need to be easy to implement from Esther, ChallengeDB, or whatever BI application. It's so easy to publish the information like JDBC. Okay, so let's see a little example from. It's a very little project, but for me, kappa-architecture work fine in little one, very big one. I use almost in all my projects. How many of you know about the OBD2 interface in the cars? You know this connector that is in the cars, and you can get a lot of information from the car. Even you can send messages, and even you can drive your car with your computer. It's the way to access to the car. Okay, so one of our customers want to put one device with Bluetooth and get a lot of information from the car and storage this to make a lot of different business projects. It's something like this. This is very classic. 5 years ago, the way to solve this thing was a kind of architecture like this. You have a mobile application that connects via Bluetooth to the device, goes for the information, send out the information using REST API to the web server. In this case, the web server was implemented with Rails, and the information was stored in a database, in this case on MySQL. Okay, very, very classic. So easy, very fast to implement. In a couple of months, you have this working fine and solve all the little problem with this. Okay, Sorry for my cough. I had I am finishing a flu, a very terrible flu. Uh, I'm sorry for the flus. Uh, the first problem we had is that when you had a lot of requests, when you had 50, 100 requests per second, there is not a problem. Almost every language, every server, even 5 years ago, can manage this. But when you starting having thousands or 10,000 of requests, you starting having a problem. Uh, Another problem is the MySQL didn't scale. When you had 100 million records or 200 million records, you have a problem, and it's very difficult to load a cluster on MySQL. So it's a bad decision. It's very fast to have an MVP product, but it's not a good idea at the end. Okay, and this work, but this only work if you wanted to, and you can try to optimize this architecture for only getting a lot of data stored. Okay, but if you wanted to make some real-time expensive queries, the problem is that you need a more powerful server, and you need to think about another architecture. Okay, more or less this is a little table with some data. At the beginning, the data only we get the data every second. Take samples at every second 60 seconds. Okay, this is not too much information. More or less, the data that is published by the cars is 50 parameters and values. Okay, if you have an expensive car, you can have even 300 parameters, and this is duplicated because they have two CPUs to control, two systems to control every part of the car. So if you, after 2 months or something like, they starting to make the sample more frequently, about 15 seconds, and you see the numbers only with 10,000 uh, users, and you have about more than 30,000 requests per second. The daily data is about more than 300 million of data every day. So that's not work with MySQL and the previous. So we started working in this project, and the first things we do is we can solve this with Kafka architecture. So the first thing was uh, uh, build a Kafka server just only to get in the request, because MySQL don't was able to store the information. Was okay, we got the request to storage, sent to the Kafka messages system, and after that there is a consumer that is storing in MySQL and its space. Okay, just only with this we started solving the first problem, but we started making more producer and starting more things. The first things we did is, okay, we will storage the information and the data we are getting in another system. The first ones was in JSON, but starting using Parquet, Avro, even Cassandra. And the important thing is that we don't need to stop the thing. I mean, the system was working, and we're starting to make new producer to starting trying things. So what is the best thing? This is another amazing thing of the Kafka architecture. We can start in putting some pieces, some producers, and starting testing things without don't stopping the production system. Okay, so at the end, we uh, we uh, we stopping the MySQL server. We started using Cassandra. Cassandra is a time series NoSQL database. It's not my favorite one. I really. Uh, how many of you use Cassandra? Or talking, and you are happy with Cassandra? Okay. Okay. I don't like Cassandra because at the end you need to define how is the way you will store the information, because if not, you cannot retrieve it fast. I think it's a kind, but just remember me the SQL database, so but it's a kind of my problem. I think Cassandra is a good NoSQL database, but it's okay. So that for that project work, and we are so happy. With this structure, at the same time in real time, we can start to do it real time dashboard without don't need to send a lot of requests to any database. Okay, forget to try to do that with MySQL. Even we don't need to send a SQL statement to Cassandra. We can get the information in real time and just publish this information in Kibana, Elasticsearch, whatever. On doing. Even we can do SEP, and SEP is a complex event processor. Okay, it's a kind of technology only to hoist it's a generic name for things like this. The type of query my customer like, and this is only one example, and wanted to do that every 10 seconds, every 5 seconds. Remember that trying to do that against MySQL database is about 1 minute or 2 minutes of the query. So it's impossible, and you're stopping all the flow of insert because it's a more or less a heavy SQL statement. Okay, but this is the kind of thing he likes to do in real time. How many drivers are not clients of the brand S and have a few gas in the deposit, so they need to go to the gas station, and if there is near of the brand S that pay money to send new customer to them, and after that sending a notification to this driver, get this notification in the mobile app, and get a discount. Okay, this is not very difficult to do. Oh, sorry for the connector, but this connector, this is not very difficult to do that, but it's so expensive. But if you are doing that in this structure, it's so easy to make just a task that running in Spark streaming, even a specialized producer that is getting this information and solving this. Okay, so just for finish, for this is a very fast introduction in the Kafka architecture. I recommend you to get the book and the I recommend previously the I Heard Love. Now is freely available, and if you don't want it to register, send me an email. I send you one of copy, and you don't say that I send you the copy, okay? But there is no problem with this. For me, it's the more important thing is a kind of pattern. Perhaps it's not the silver bullet for every solution, but I use all the time with my project, and I'm very happy to solve this. Kafka Mass Spark Streaming is my favorite, and one of my favorite tools. I wanted to to point you to Graph database. How many of you are using Graph database? This is a very, very important thing. I think that the traditional relational database lie us and try to convince us that we need to put the information in column, in rows, or only because it's good for them. But the information, the very real way that information live is in Graph database. Very, very important. I will pass very fast. I recommend you to take a look in Apache Beam. Apache Beam is a project to implement Kafka architecture in a lot of technology. Sorry for the slide, but you can do Kafka architecture with Kafka in Spark, but with Apache Beam, you can do it in your local computer with Google Dataflow. You have a lot of options to do that. Yeah, my last slide is about think big. For a lot of years, I use it to install my own computer, to define virtual machine. The magic word is serverless. Try to use pieces that work automatic. Don't spend any time to being a DevOps. How many DevOps are in the talk? Great. This is the DevOps. He needs to do this thing, but the rest of us not. Try to think in serverless, in things that work from the first seconds, that scale automatically, that you don't need to think about. For me, it's very important Kubernetes, all the thing about notebooks, and if I need to do something like this with this kind of project with Kappa, perhaps now this is the architecture I will use, because it's almost serverless. I will use Google Function, Amazon, or Azure, or whatever, but my favorite is this. I'm a GDE from Google, so I need to say that, and I believe in that. Google Function is a serverless thing to something like the Lambda Amazon product, so it's perfect because grow without any problem. You don't need to think about server. The cost is about millions, and when you execute 10 millions of code, it's about €5. So no question. I pay from my wallet without any problem because I don't need to do nothing. PassUp is a kind of Kafka. I think I prefer Kafka, but I don't need to do nothing to start in working with function and PassUp, and the same thing is serverless and grow automatically. Dataproc is Spark in Google, and Dataflow is the way they implement Spark streaming. So if I need to store that information, I will use BigQuery, Spanner, or whatever, and do the graphic with Data Studio. And I can do that in about 2 hours. Okay, the difference with the previous project, I need 2 weeks. I can do it in 2 hours without any problem of virtual machine, cloud services, or whatever. With this is just a point. My last project, I used this kind of architecture, and that's all. I don't know. This is my email address, my Twitter address. It's very important. All my talks have a lifetime warranty. That means you can, if you don't want to do some question now, you can write me until I die. That's lifetime warranty. So no problem, and that's all. I will take a selfie because my boss needs a proof of concept that I am here giving the talk, and it's a kind of a statistic. If you smile, I can pass a machine language program and do a quick statistic. Okay. Thank you very much.